A faster press doesn't always mean more production. The press is only one clock in the line. If it completes a cycle every 10 seconds, its theoretical capacity is 360 parts per hour. Reduce that cycle to 6 seconds and the number jumps to 600. But suppose the part needs 30 seconds to heat, cool, transfer, or inspect. The line is still capped at 120 parts per hour. All you've created is more waiting time at the press. Actual throughput depends on the complete process: material preparation, loading, forming, unloading, cooling, inspection, changeovers, and whether the next operation is ready to accept the part. That's where well-designed automation can make a measurable difference. Automated loading and unloading reduce the variation that comes with manual handling. Transfers can begin as soon as the press reaches a safe position, while robots, shuttles, or conveyors coordinate each step instead of treating them as separate events. Some operations can also happen in parallel. One blank can be heating while another is being formed, and a finished part is cooling or undergoing inspection. Buffer stations keep a short interruption downstream from stopping the press immediately, while sensors and inline inspection identify process drift without routing every part through a separate manual check. Automation can shorten changeovers too. Automatic die handling, stored recipes, programmable motion profiles, and guided setup routines reduce the time between the last good part of one run and the first good part of the next. But automation doesn't eliminate bottlenecks automatically. Poorly balanced automation can simply move the queue somewhere else, often to cooling, inspection, or downstream processing. So don't evaluate a press by stroke speed alone. Map the full cycle, identify which operations can overlap, and measure throughput in good parts per hour. That's the number the entire line must be designed around.